Hi guys, welcome to the Logic Tree Institute. So in this video, we are going to derive how to calculate the present value of an annuity. So let's starting with the first is annuity. Annuity is defined as a series of equal cash flows. So if I take an example, the common example is EMI. EMI stands for easy monthly installments. So this is you pay equal installments over a period, let's say for 1 year or over the 12 months, you pay an equal amount to the bank, and that will include your repayment part, principal repayment part, as well as your interest part. Another example of annuity is salary. So for 1 year, or I would say 12 months, you receive equal amounts from your employer. So that is an annuity. So if I represent it over a timeline, it can be represented in this form, where A is the equal installment or equal payment that is either received or paid over a period of time till T is equal to N. So if I briefly say, annuity can be classified into two types. First is ordinary annuity, and the second one is annuity due. This classification is done on the basis of timing of cash flows. So ordinary annuity includes the payment or receive of the cash flow at the end of the period. So this is when I am paying or receiving the money at the end of the period for n number of years or n number of months. While annuity due, in this we receive the payment at the start of the period. If I take an example of ordinary annuity is your salary. So you work for the whole month and you receive the salary on the last working day of the month. While if I take an example of annuity due, this will include your EMI. So you pay your EMI on the start of the month. So you are paying on the start of the month, while salary is the payment you receive at the end of the period. Moving further, if we have to find the value of ordinary annuity, that is we are receiving the money at the end of the period. So the present value of a series of ordinary and a series of equal cash flows is given by this formula. In books you will find this formula, but generally the derivation is not given in any book. So if we have to derive, let's say R is my rate, R is my interest rate, and N is the number of periods. So if I have to find the present value of this ordinary annuity, then this present value will be equal to the present value of this cash flow, that is A upon 1 plus R. This is derived from the formula of FV is equal to PV into 1 plus R raised to the power N. So for this A, N is 1. So we can write PV is equal to FV upon 1 plus R raised to the power N. So here I am paying or receiving A amount after one period. So its present value will be A upon 1 plus R. While the present value of the second cash flow that I will receive or pay at the end of T is equal to 2, that is after second period. So its present value will be A upon 1 plus R square. Continuing further till T is equal to N. So present value of the cash flow at T is equal to N is given as A upon 1 plus R raised to the power N. Even if I write one more term, so it will be in this form. Now from this series I am taking a upon 1 plus r as common. So the series will become 1 plus 1 upon 1 plus r plus 1 upon 1 plus r square. Continuing further, 1 upon 1 plus r raised to the power n minus 2 plus 1 upon 1 plus r raised to the power n minus 1. So this series, what we have formed here is a GP series, that is geometric progression. So if you remember, a GP series is a one whose numbers are in constant ratio. If I take an example of 2, 4 and 8, so the ratio of 2 and 4 is 4 upon 2 is equal to 2. And if I take 4 and 8, the ratio is 8 upon 4 is equal to 2. So here the ratio is remaining constant. So the sum of any GP series is given as a into 1 minus r raised to the power n upon 1 minus r, where r is the ratio of the series and r is less than 1. So in my case, my ratio is 1 upon 1 plus small r. So this fraction is always less than 1. So I can apply this formula here. So my present value will become is equal to a upon 1 plus r. Small a is the first term, that is 1 into 1 minus 1 upon 1 plus r. So this term raised to the power n. So here while I have written term n minus 1, but it has started from 1 plus r raised to the power 0. So there are n terms. So I have written here n, not n minus 1. This whole divided by 1 minus 1 upon 1 plus r. Now taking LCM in denominator, it will become a upon 1 plus r into 1 minus 1 upon 1 plus r raised to the power n upon 1 plus r minus 1 upon 1 plus r. This 1 plus r and this 1 plus r will get cancelled, and this 1 and minus 1 will get cancelled. So the present value will come a upon r into 1 minus 1 upon 1 plus r raised to the power n. So this is how you derive the formula of present value of ordinary annuity. Moving further, the second case is of annuity due. So in case of annuity due, we are getting the payments at the start of the period. So here, if I consider the case of the ordinary annuity, so I was receiving this payment at the end of the period of t is equal to 0. So I was receiving the money or receiving the cash flow at the end of the period. While in case of ordinary annuity, I am receiving it at the start of the period. So this cash flow will move here. So it will move one step further. So the next cash flow will receive at the start of the period 2. That is, this cash flow will again move ahead to t is equal to 1. Similarly, I can move all the cash flows one step ahead. So this series will comes around in this form. Again, if I have to derive this present value of this series, then it is given by this formula. So guys, you don't have to remember this formula. With this video, you can easily know how to derive this formula. So even that is, instead of memorizing the formula, you can derive this. So that will be much easier for you. So if I take, or if I want to find the present value of this series, so that will be equal to the sum of present value of all these cash flows. So if I write this a is equal to 0 occurs at t is equal to 0, so its present value will remain a, while this a occur at t is equal to 1, so its present value will be given as a upon 1 plus r. Moving ahead, this a will come at t is equal to 2, So its present value will be A upon 1 plus R square. Continuing till T is equal to N. So here the cash flow will come A upon 1 plus R raised to the power N minus 1. So now I can take A common from this series. So it will become in this form. This is the same series which we have derived earlier. So this is equivalent to this series. So again this is a GP series, and the sum of the GP series is given as A into 1 minus R raised to the power N upon 1 minus R, where R is less than 1. Here R is equal to 1 upon small r, 1 upon 1 plus small r. So the sum of this series we have already derived is equal to what? 1 minus 1 upon 1 plus r raised to the power N upon 1 minus 1 upon 1 plus r. So if I write this, it will become 1 minus 1 upon 1 plus r raised to the power N upon 1 minus 1 upon 1 plus r. So taking 1 plus r as LCM, I will get 1 minus 1 upon 1 plus r raised to the power N divided by 1 plus r minus 1 upon 1 plus r. So here I don't have any term. Like in previous case, I was having a term of 1 plus r in the denominator of this fraction. So that was getting cancelled here. So I don't have such term in this case. So this 1 plus r will get multiplied above. So it will become A into 1 plus r. Now in denominator, this one and this one will get cancelled and we will get r into 1 minus 1 upon 1 plus r raised to the power N. So the formula becomes the present value of a series of equal cash flows starting at the start of the period is given as A upon r into 1 plus r into 1 minus 1 upon 1 plus r raised to the power N. So guys, this is the derivation of the present value of an annuity due. Moving ahead, if I have the case of perpetuity. So perpetuity is defined as a series of equal cash flow for infinite number of periods. So it is an annuity with infinite life. So here T is equal to infinite. So N is my infinite. So the present value of this series is already we have calculated or derived. So this was A upon R into 1 minus 1 upon 1 plus R raised to the power N. Now guys, note, whenever in the denominator I am increasing the power, let's say if I consider 1 upon 2, that will come around 0.5. If I take 1 upon 2 powers 2, so that is equivalent to 1 upon 4, this will come around 0.25. Now again if I take power of 3 in denominator, so it will come 1 upon 8, that is equivalent to 0.125. So now if I see, as I am increasing the power of the denominator, my fraction value is decreasing. So if I increase n or I increase my power till infinity, so this term 1 plus r raised to the power n will tend to infinity. So it will become PV is equal to A upon r into 1 minus 1 upon infinity. Now 1 upon infinity will tend to 0. So this will become PV is A upon r into 1 minus 0, or I can see PV is equal to A upon r. So this is the derivation of a present value of perpetuity. So now we have derived the three important formulas for ordinary annuity, Second is your annuity due, and the third is perpetuity. You will not find these derivations in book whether you are going for CFA or FRM. So this is the derivation, this is how you derive this formula, and using these derivations you don't have to remember the formula, you don't have to cram the formula. So this derivation, I hope this video will help you to clear your concept of the time value money, and this will help you to how you derive the present values. If you like the video, please like and subscribe. Thank you.